Welcome to this video. This is Said Ahmed from Toronto, Canada. So this video will be on the stock price prediction using some graph neural network and other machine learning methods. So this is just a part of the continuation that we are doing so far. So let's see what we actually were doing, and then I'll say what this video is about. So Google Chrome. So on YouTube, the corresponding channel is, I hope I find it. Okay. So as of the last one, okay, I think I showed previously that how can you use YFinance module, Python module to scrap financial pricing data by day or by minute. Okay, that's okay. So and then previously what we did some stock price prediction using some graph convolutional neural network. It's just graph convolutional neural network and the multi-layer perceptron. There is nothing there, right? So, and we used some NASDAQ data that was downloaded from Kaggle or somewhere. Now, one thing is the performance did not look great and the prediction result did not seem great either. Now, so yeah, it could be a data issue. Now I use this YFinance tool to find out the data for 30 stocks from 2017 to 2019. It's actually also grabbed data, the same stocks I used that the research paper was doing, right? So stock price prediction. Okay, this is the research paper that I'm trying to implement, right? So this is the one. There are some viewable PDF version online. Search for it, right? Okay. So they used 30 companies from the Fortune 500 companies. I used them 30 companies, but it looks like two of them or one of them. For one of the stocks, the data is not there on Yahoo Finance for whatever reason. Probably the company is out of market or something. Anyway. Okay. What I was doing? Okay. So I used a simple GCN. I used some NASDAQ data from Kaggle and using some graph GCN graph convolutional neural network MLP is predicting price. It was not great. The prediction or the performance, right? Now is YFinance. I grabbed some data for those 30 stocks as per the paper, and then I ran it, and the performance actually looked better. The performance looked significantly better the previous one, and it might be the case the prediction are also almost good, but I think I need to do a little bit more on this to verify. Okay. So step 11, step 10. Okay, step 10 and step 11. I think it will be under the playlist stock market price prediction. Okay. Okay. Under this step 12 and step 10. So if you watch those, then you will get the context and then you'll be able to do it. Okay. So here I am, right? Okay, simplest model. Let me see. At the same time, I will try to update a presentation document if I want to carry the information to others. Okay, so in that case, I probably need to keep my screen sharing on. I wish I could keep multiple application open. Yeah, other than sharing the entire screen, if I could just open multiple screen at the same time and share it. Okay, I'm just positioning things. Nowadays, it looks like especially if my computer configuration got changed for any reason. Okay. Okay. So, yes, I think there is one another change in strategy. Previously, I think what we are doing from the stock market data, depending on the correlations among the stocks, how they related their prices movement together or not, we are creating some graph, right? Just to represent the relationship, whether there is a correlation or not. Okay. So yeah, so Pearson. So there are 4 different correlations that we're using for different graphs, right? So this was from the step 11 or step 12. Now this will be step 13. So probably step 11. So this is step 13 video, right? So let's say, so how do those look like, the graph? So this is Pearson, right? Let's copy it. Okay. So Pearson, it looks like this. Okay, the paper used correlation greater than 0.5, they put into the graph, but I believe I made greater than 0.6 because it becomes a little bit sparse. My perception was the previous one was not giving good result because probably the graph was more connected to each other. So that's why I think I can change it to 0.5 to reflect the paper itself. Now let's say I want to do the Spearman graph. It may look like the same, but in Spearman correlation, we are using 0.4. Okay. So it might be here. Let's say Spearman. Yeah, I think some of those things is Spearman. Where is the graph? Yeah, it's all in one block. So okay, this will be the Spearman. And before that, I need to ungroup this because I sort of grouped up. So does it look more dense? Yeah, it sort of looks that there are more connections here than here. Okay, now ungroup this one. Okay, now I need to see where I kept the Kendall tau. This will be one big block. And then the output. Okay, Kendall tau model. Okay, yes. Predictions. Yeah, there will be network X related draw function. Okay, where is the correlation? Okay, it might be another block, maybe. Okay, let's see. Kendall route. Okay, so okay, this is the correlation. So the graph is supposed to be there. Stellar graph. Okay, let's see. I believe still I'll be able to plot it here. Okay, I need to separate out. I think what I did in the Pearson, the code was in separate block, but then I copied everything for the Pearson and then moving into a separate one block. And then I think I need to separate it out. Okay, they look the same, but still there must be some difference. Oops. So I need to, okay, it looks like I need to delete one. Okay, so this is the graph. I think the previous graph and now graph, it looks definitely different, and financial news based that is in a different. I believe it. I could bring it here, and then do the prediction. Okay. Now methodology. I think we probably have told it, said it in another case. Let's see. Result. Previously, I tried to keep Pearson in one file, Spearman and Kendall in 3 different files. I thought that they will be a separate experiments. Keep it separate and bring that up. Now it looks like I will do it the slightly different way. Each one I will keep one. I think in each file, all Pearson, Kendall or GCN, Kendall, Spearman, everything will be in one file, right? However, the model will be different. Each file will use a different model. Each file will use a different model and then apply on the graph and find out the result, and then I'll be able to compare how those different approaches work, Spearman, Pearson, how they differently work. Okay. So initially my goal was implement the paper as is and then try to improve it, right? Now going close to the paper, that will be one of the goal, right? And then improving it will be another. So it may be tricky to go to the exactly the paper implemented because not all the fine details, fine grained details are mentioned there. I need to assume and then try to go there. Now, initially it seemed they used GCN layer and the CNN layer, right? Now, if I read it here, it looks like they have used graph convolutional network. CNN is built into it. That's what appeared. It probably looks both right and wrong, but eventually, if I try different ways, then I will know. At this moment, I just use GCN and MLP, right? In next step, I think I actually tried in different configurations, try to make something like graph convolution and CNN, and then graph convolution and CNN. So I tried to make it like this, but that didn't go well, right? But I probably will need to go back and see where things needs to be adjusted so that I can make it like a graph convolution and CNN, and then graph convolution and CNN. Now, one more thing I need to see inside the GCN library code that I used, if there is any CNN layer built in. It looks like no, that their code don't use the CNN inside. Now, on another note, I also need to check the paper or the general concept of graph convolutional network. Do they mean that there will be a CNN layer or this graph convolutional network, because it works like a convolution using graphs, so there is no separate CNN layer. So there are some things, some confusion to clear, and then depending on that, I will also need to clear those. Eventually, my goal will be going to the close to the paper and then try to do something different, see how things go. Okay. So let's say in terms of trying to predict, I think it's a regression problem. Yeah, in graph, you can do both regression, prediction, regression, classification, clustering. all of this, and sometimes it can be related to node, it can be related to link. That's a different concept, right? Theoretical. Okay, so now let me find out the, not here, f dot corr correlation. Kendall, I don't want Kendall, I want to the basic one, Pearson, right? Okay, now I'll bring all the loss functions there. Actually, the image, so it will be after train test and probably the when eval what or fit, even after compile. So this is the compile block. Okay, we'll be measuring this mean squared error, mean absolute error, mean absolute percentage error. So I'm trying to fit. Okay, let's copy this image. Because this result is no longer valid, I will remove this. Okay, it's gonna be a, okay. Yeah, I think ideally, okay, so loss, train, and validation. Yeah, looks like they are matching. However, the mean absolute percentage error, that probably is doing some, not showing the best result for Pearson. I can take it little up. So, okay. Yeah, mean squared error, it also looks not that bad, right? I use 1000 iterations, 1000 epochs, and the learning rate 0.15. Another rate, I use dynamic learning rate, but that time the model or the data was different, but it didn't look like the dynamically using learning rate actually helped. The fixed one help, but ideally, yes, conceptually, theoretically, in many cases, dynamic adjustment can help. You start a little bit bigger and then you go smaller learning rate. Okay, now, so this is the data. Let's do it insert text box, and put it there. Probably something didn't go right. Let's open it. Okay, it probably is doing something else, and I want to do it here, right? So, okay, what is this then? Okay, looks like there is some connections between this and that I was not expecting, but this is what it is. Okay, it looks like unless I create multiple lines, now I need to make it bigger, otherwise this guy will not. Okay, so loss, I think I can make it just mean squared error. Okay, so MAPI, it looks like 118%. So usually this can go up to 200% MAPE. I think in several ways it may not be the best measure to use. It probably I'll need to see that in terms of how it compares with other approaches, that probably where it will add value. it just tells in general the prediction is being higher. Predicted stock price will be higher. That's what it does mean. Okay, so that is for Pearson, right? Now let's check the model. So yeah, it's a simple model. But you can see that loss is not a huge number, mean squared error. Okay, mean absolute error. Okay, I think we can make it better. Okay, let's see. Here, mean squared error. Okay, let's like it probably don't match that much. Okay, what is the code? Fitting is fitting, right? Epochs, validation, data validation. This is the train data, this is the validation data. Okay. It is just we are doing the compilation. What is the loss and what we want to measure? Okay, it is just the GCN layer, 32, 32. You can even try only 32. That will also work. 32 and ReLU. Generator, it is come from the graph. I think we create the graph and then the stellar graph library. We use the full batch generator. Okay, it is just getting the data. And let's see, in terms of we are using per day fortune 500. I think it is used from the Y Finance. If you go watch our previous video, step 12, I believe you'll see it. We take the data, and that's how the data looks like. We try to replace null values, but I think for this data, just only one columns. So it probably will be giving some exceptions. So interpolating anyway, but I think we probably can just remove it. I think that's what this next step will do. So you're just dropping it, the corresponding column. Axis 1, that means Y column, where it is null. Let's step. Next time I can try it with a 0.5 because that's what the paper used for Pearson. Yeah, Pearson correlation, we're just finding out if greater than 0.5, then 1. Now this diagonal element, that is a self flow, and I need to remove it. So the field diagonal, that's what it is doing. And then it is a network X. I'm just trying to plot it. So I'm just trying to find out all the time series for all of the stocks. I think it is in the data, just I need to format it in such a way so that I can separate as part of the graph convolutional neural network or the overall architecture, right? So for all nodes, okay, let's say another thing is to create the graph. To create the graph, I use a stellar graph. It has some specific format. We need to give node data and edge data, right? Okay. Yes, which actually is not required for the for my purpose. So okay, where is the graph creation? Okay. Okay, they're just manipulating the data to make it work. Okay. Okay, here I am creating the stellar graph, and this graph data is coming here. Each data, I did not use the one that has the weight, right? So full batch generator from that, formatting in such a so that it can be fed into the graph convolution. This is dividing the data. I think 21 stocks is for the training and 7 is for the validation, but the graph structure is totally passed. Okay, unit count. Okay, I believe I tried to use it. Okay, let's see. I wanted to use it in terms of the how many layers or how to not those kind of things. But anyway, okay, then epoch and then okay. So that's all it is. Now this is the predicted price. Okay, I think previously we had all the rows were same. I think all these arrays were same, but now it's different. I saw that they are reflective of the prices. So this is the predicted price, and these are the already price. Already price is here, and there's the predicted price. Okay, now go to the Spearman. So I took the graph. Now I need to take the data, right? The result. So it is here. Okay. Okay, there is not much point in showing the picture again. Okay, let's still copy it. I think I was saying because there may not have enough space, right? There may not have enough space. And on another approach can be, I can keep this side by side and definitely equal size. The Pearson and the Spearman. Let's take the Spearman data.